Manual operation. This lesson mainly explains the manual teaching operation of Jaka robot, including the following contents: robot joint teaching, teaching coordinate system selection, position teaching, step teaching, manual input teaching. This class lasts about 15 minutes. Course objective is 1. To understand the teaching method of the robot. 2nd, to be able to control the robot to move to the target position. Jaka robot is composed of 6 joints. Each joint can move independently. Slide the virtual joystick on the right side of the interface and hold it there. The corresponding robot joint will immediately rotate in the corresponding direction. When the joystick is released, it will return automatically to the origin, and the robot will immediately stop moving. Take a look at the video of the joint teaching below. Drag the joystick to teach points. Then the movie spin below to control the spin during teaching. The movement speed can be entered manually. The 6 joints of the robot can be taught individually. Note that there is a movement speed directly below the operation interface in the end. When dragging the rightmost 100%, the speed at this time is about 1/3 of the maximum joint speed. The joint position keeps changing after enabling, and the position remains unchanged after enabling. This is a normal phenomenon because after the enabling, the position feedback data of each joint encoder is displayed. After enabling, the data here is the data of the position command. Switch between tool coordinate system and user coordinate system. In order to facilitate teaching, the Jaka robot supports teaching movement in the tool coordinate system and in a user coordinate system. The position of the robot base has the red, green, and blue coordinates, which is the user coordinate system. When the offset of the user coordinate system is all 0, it corresponds to the world coordinate system. Also, there is a red, green, and blue coordinate system at the end tool of the robot, which is the tool coordinate system. And when the offset of the tool system at the end of the robot is all 0, it is the end flange coordinate system. As you can see, there is a button to switch the user coordinate system and the tool coordinate system in the robot teaching interface. After clicking the switch, the corresponding icon on the right will turn red. Now check out the video below. Click the Switch Coordinate System button. You can select the user coordinate system or the tool coordinate system. The user coordinate system can select the world or the 10 user coordinate system in the settings. Tool coordinate is the same. The user coordinate system is a static coordinate system. After adjusting the robot's posture, the direction of the coordinate system remains unchanged. The teaching of the robot is still moving in the original direction, and the tool coordinate system is a dynamic coordinate system. After adjusting the robot's posture, the direction of the coordinate system changes, and the teaching direction of the machine also changes. In the user coordinate system, the end of the robot will move along the coordinate system direction of the boss position, like on the video. Linear motion or rotational motion around a straight line. Sliding the X-axis joystick to the right means moving to the positive X direction. Slide the Y-axis joystick upwards means moving to the positive direction of Y. Let's have a look at the video. In the teach of the X-axis direction in the user coordinate system, Then teaching of the Y direction in the user coordinate system. And at last, let's look at the teaching of the Z in the coordinate system. For the rotation, in the user coordinate system, Rx rotates and teaches, and the robot rotates around the x-axis. In the user coordinate system, every rotation teaching, the robot makes the y-axis of the user coordinate system rotation. And finally, in the user coordinate system, RZ rotation teaching, the robots make a rotation around the user coordinate system z-axis. In the tool coordinate system, the end of the robot will move along the coordinate system direction of the end flange position. Move in a straight line or rotate around the straight line. Sliding the x-axis joystick to the right means moving to the positive x direction of the robot. The same for the y. Sliding the joystick upwards means moving to the positive y direction. Okay, now take a look at the video. The x-axis direction teaching under the tool coordinate system, the robot moves along the x-axis of the tool coordinate system. The robot moves along the x-axis direction after the change, and the y-axis direction it starts in the tool coordinate system. The y-axis direction changes after switching the robot posture. Teach along the y-axis, the direction of the robot movement will also change. Then, teaching in the z-axis direction in the tool coordinate system. Now about the rotation. Rx rotation teaching in the tool coordinate system, the robot rotates around the tool x-axis. The tool is used as a tool to teach the rotation of Ry. So for Ry, the robot rotates around the y-axis of the tool coordinate system. For the RZ, the tool is used as a device to teach RZ rotation. So now the robot will move around the Z-axis of the tool coordinate system. By dragging the movement input bar at the bottom of the manual interface, the speed of the robot movement can be adjusted. You can also click the percentage above the movement bar to enter a specific percentage. Speed, joint, and the linear motion also support fixed motion, and the step value is on the left and right side respectively. Now take a look at the video. So set the moving speed below, and you can control the speed of the robot. Then you can also select the step value. So choose the step to change the fixed angle, then choose the continuous, and the teaching move will go continuously. After selecting the step value for position teaching, the robot moves a fixed distance. Select continuous for continuous movement, and the more the step value will be small, the more precise movement of the robot will be. Manual input operation. Input the target position, the usual coordinate system, the desired target, and let the robot move in a way of joint or linear motion. Click any position information box on the manual operation interface to enter the position movement interface. First, if you need the robot to move to the specific joint motion, enter the end position of the 6 joints in the joint position area. Press and hold to move to this point. The robot moves to the specified position. Click OK to exit the position movement interface and complete the position movement. Second, if the robot needs to move to the specified space position, enter the endpoint space coordinate system in the tool coordinate system position area. The same, click to calculate the joint position, press and hold to move to the point. After entering the target point, you can choose to move to the target by joint or in a straight line. The difference is that there are singularities in linear motion. And any robot has singularities, which is related to the design of the robot. For points that cannot be moved, joint movement is recommended. Watch the video. Enter the Cartesian coordinate system and click Calculate. Move linearly to the specified target point. Enter the x coordinate -50 and click Calculate. When the linear motion reaches the singular point, the robot is protected and stopped to try joint motion. The robot can move normally. The joint motion of the robot can normally move from the place where the x-coordinate system is at 222 to the place where the negative coordinate is equal to -50. Now use linear motion instead, and the robot reports the starting point to protect stop. Go back to the original place in the same position. The robot can move normally in the way of the joint movement. This is the end of this lesson. Thank you for watching.